Hello, everyone. This is the cluster API provider for Bring Your Own Host office hours of 9th February 2022. We abide by the CNCF Code of Conduct. If during the meeting, if anybody has any questions or comments, please use the raise hands feature. And I think let's get started. So we have a few items on the agenda. Is there anything you all want to add? Probably you can add in the meantime. So let's start with the VYH cluster create workflow. So last week, sometime Dharmjit and I took some time to create a sequence diagram for VYH cluster create operation. So this is fairly simple, so I'll just be quick about it. So the user downloads the host agent binary on the host agent. Okay, there are different actors. One is the user. We actually have different persona defined as a platform operator and as a site operator. So site operator usually deals with whatever is on your bring your own host, that is the host side, and platform operator usually deals with the management cluster side. But for this diagram, we have just considered that persona to be a user. And then we have management cluster, and then we have VM or bare metal host or container host. It could be any host. And then we have an OCI registry. In our case, it is Harbor. So the first thing the user does is to download the host agent binary onto the, let's say, VM host. And then the user has to start the agent and has to provide the kubeconfig file. So this is required to talk to the management cluster for creating CRDs and watching CRDs to establish that first communication with the management cluster. So once the agent process is started, it will register as a new CRD, and it will also watch for the particular Pivat CRD that it has created. And once this is registered, this is considered as joining a capacity pool. So any number of BYO hosts that come up join this single capacity pool. Now, next, the user will apply a cluster template that says, this is my BYH cluster with any number of control plane and any number of worker nodes. And the user applies the cluster template, and the API server creates all these CRDs like BYO machine, BYO cluster, and the BYH provider in specifically, yes, Avishai?
Sorry, it took me a while to find out how to raise my hand. When you wrote that the agent registers and watches, just to clarify, you don't mean like Kubernetes controller watch. It's some code that is polling for changes, or
this watches the Kubernetes controller watch itself. So just like any other controller will watch for events on that particular CRD, this is the same thing. It will not specifically poll for it, but we have this manager part of the code, right? Wherein you can register what all CRDs you want to watch for.
Right, but at this point, the host isn't running Kubernetes, right? It's not a node. Like it.
No.
Is it an actual controller running there, or just generic?
Yes, this is an actual controller.
Okay.
Yeah, but it's still not a node at this point.
Correct.
Yeah. So next, the user applies the cluster template, and this creates all CRDs like BYO machine and BYO cluster that are defined in the cluster template. Now, the BYH provider, in particular, we have BYH cluster controller and BYH machine controller. Now they're notified that their CRDs are being created, and that's where the reconcile loop for these controllers kick in. So there are a few precondition checks that we are doing, like checking if there's a paused annotation set, checking if there are owner references set, is the data secret ready. So after all these checks are done, so this is part of the cluster API contract. So we have to abide by these checks. So when all of this is ready, it will now look for the actual infrastructure it has to get attached to. That is where it will query for all the list of available hosts. Now here we can specify some labels, like if you have added any labels on the BYO host at the time of, say, CR creation, you could now filter those hosts as well. So based on that, you will receive a list of all the available hosts, and then it does the host attachment logic. At this point, we don't have any smart logic. So it is just whatever the first host is available, it picks that. So what do you mean by host attachment? So we add a few labels on BYO host saying, okay, this host belongs to this cluster, or this host has some cluster annotations. And then there are a bunch of annotations like what Kubernetes version this host needs to install. And there are a few more, I can't remember. And this is the main part, that is the status.machineref. So this field indicates which BYO host is attached to which BYO machine. So once this field is set, we patch the BYO host and set the BYO machine status to ready. But once this host is patched with all these details, now the agent reconciler, so this is the actual controller that's running. So this receives this reconcile event saying, okay, there's some updation happened on the BYO host. Now the reconcile function here will kick in. Again, there are a bunch of precondition checks that we do, like paused annotation, seeing that it actually has a machine ref field and it has a bootstrap data secret field. Once all of this is done, it means now it is ready for bootstrapping into a node. It means some BYO machine has selected it. Now it has to bootstrap itself. That's where it will download the BYO image package bundle from the OCI registry. So this image package bundle is nothing but it's an OCI artifact that contains all the K8s components like kubeadm, kubelet, everything that's needed to bring up a Kubernetes node. So we bundle that as an OCI artifact. So the first thing it does is downloads this artifact and then runs kubeadm, whether it is kubeadm init or join. It depends on whether it's a first control plane node or remaining nodes. And once the kubeadm operation is successful, it means your node bootstrap is successful. So then we patch few conditions saying, okay, this is successful. And in any of this process, if something goes wrong, we set necessary condition and failure reasons so that the user can know what failed at what stage. So after you get this K8s node bootstrap succeeded condition to true, it means your cluster is provisioned, and then you can go ahead with CNI and any other operation. So this is the basic cluster create workflow. Any questions?
No, very good.
Okay, thank you. So, okay, so I wanted to show this workflow as a precursor to my next point. That is a lifecycle hooks based proposal. See, Asutosh and Shailesh also joined, so some context here. So Avishai is from Red Hat, and then when he reached out to us about possible collaboration, and Richard is from Weaveworks, who is also interested in BYOH provider, but the thing is they cannot use BYOH as it is now. So we are trying to brainstorm on ideas on how we can make it, useful for everyone, and we're thinking about how we can make BYOH extensible. So there's an earlier proposal by Avishai. You can look at earlier office hours meetings. And today I want to walk through another proposal, that is the lifecycle hooks based proposal. So some disclaimers before I start this. So this is only a work in progress, not even work in progress. It's a small rough draft, because I wanted to just convey the idea of how we can use lifecycle hooks. And this talk is not thoroughly detailed on, there could be gaps, but the main idea is we want to keep the BYOH provider as declarative as possible, so that all the provider has to do is watch for CRDs, update CRDs, and then take action based on that. So with this in mind, what we started to do was, the first thing we did was to see if Cluster API does already something like this. And I found it has a machine delete phase hooks. So there, based on few annotations and watching those annotations, you can define these different lifecycle points and then break out into your own implementation. So this seemed interesting. So this doc is like heavily inspired by that. Okay, so I think let's get started. So in this proposal, we will identify different phases in the BYOH lifecycle. Like it could be cluster create phase, or node bootstrap phase. So depending upon these various phases, we can define different lifecycle points. in here in this doc, I have considered one particular example of just before bootstrapping of Kate's node, if you want to do some advanced validations. Like if we consider this sequence diagram, so this is where we download the BYH bundle and node bootstrap begins, right? So just before this, if you want to do advanced validations, like I remember Avisha had a use case wherein you want to see if the host is in the same network as the remaining hosts in the cluster. So only then you will allow the host to be joined. So things like that, or if there are any other checks that you want to do, because right now BOH does not do any such checks. So if there's something that's very specific to your use case, then we could use this lifecycle point. So yes, the goal is now to first define an initial set of phases. And then for each of these identified phases, we will define an initial set of lifecycle hooks. Yes, Ashutosh.
One question, maybe like no question, but I see that Cappy had something going on with runtime SDKs. Like I'm trying to see like how is it different? Because if I'm not wrong, runtime SDK gives you the flexibility to define events in the provider's life cycle, and you could actually write your own implementation of the hooks. I mean, this is in progress, so we don't have any like consolidated or concrete ideas yet. But yeah, just trying to see like if this could actually fit into those work.
That's a good shout. So I found out about runtime SDKs just today morning. Oh,
okay, no problem.
Yeah, so that's why I have it open. I want to talk about it in some time. Yeah, bear with me. I'll come to that. Okay. So we have initial set of phases, and for each of the identified phases, we can have initial set of lifecycle hooks. And also we need to have basic expectations defined for the BYH controllers. And some of the non-goals are like, we don't have to right now care about how these different lifecycle hooks are ordered or in what order they are called. So I'm just trying to scope it out for now to keep it simple. And again, this glossary is what you can find in the CAPI proposal too, that a lifecycle hook is a specific point in a CR's reconciliation where the regular reconciliation will be paused. And then the hook implementing controller is something that is external to the CR controller. And this is responsible for adding, removing, and responding to these lifecycle hooks. So the basic proposal is to introduce a new lifecycle field on each of the CR specs. And this field can be used to register the hooks. And we can use annotations to indicate to hook implementing controllers that, okay, now it is time for you to take some action because the hook you're interested in has been added. And each lifecycle point can have 0 or more hooks. We do not enforce ordering. And whenever any hook is found or added during CR reconciliation, we will effectively pause this. And it's not the job of the CR controller to remove this, and it's only the job of the hook implementing controller to remove these annotations. So as a simple example, I've stated pre-Kate's install. This is just before you start installing Kubernetes components. And if you want to do any use case specific validations, this should be your lifecycle point. And let me straight away go to this. So this is our BYO host spec as of today. So this is the new field that I added. So in this lifecycle point, lifecycle field, we should define different lifecycle points here, like the pre-Kate's install. So this can hold a bunch of lifecycle hooks, which are nothing but simple strings. So if I have controller A and B who is interested in adding a lifecycle hook, they can both register to this particular lifecycle point. And the agent reconciler should be smart enough to understand during its normal execution, which lifecycle point it has reached. So I say that, say the reconciler started executed from here, and when it reached up to this point, it has to understand that, okay, I have reached a particular lifecycle point called gates pre-install. Let me check if there are any hooks registered at this point. If there are any hooks registered, then add those hooks as annotations and then patch the particular CRD, in this case, BYO host. So when this BYO host is patched with those annotations, the controller A and B who had initially registered for these hooks are now aware that the annotation that they are interested in is available on the BYO host. And therefore, they can start, their reconcile process or validation or whatever there is they want to do. And once that all of their operations are complete, they have to remove the annotation on the BYO host. Otherwise, the agent reconciler will just wait forever for that annotation to be removed. So this is a small implementation. Yes, Avishai?
Maybe before I go, Shutosh asked in the chat, are life cycle points defined by BYOH? I believe yes, right?
Yes, because this is for the life cycle of a BYOH cluster.
So,
does that answer?
So let's say I want to write a new controller that implements this lifecycle event that needs to be registered in BYOH first. I mean, BYOH should have all the defined lifecycle events or that point, and then only we could actually implement that.
Yes. So if I define only pre-K8s install as of today, and you want for a different lifecycle point, first you have to come and PR it here first. Yeah.
Sure.
Yes, Abhishek.
Okay, so a couple things. I like this. I like this pattern because it, as opposed to my proposal where it was kind of like, if it's Red Hat's implementation, then call this code, and if it's VMware's implementation, call that code. This allows more decoupling. Like you can split each implementation into a different controller. I think we still will need some sort of pointer, generic place to add things to the cluster machine, the BYOH cluster BYOH machine. And the only concern I have with this pattern is that the implementation specific controller needs to be synced with these lifecycle hooks, right? Because if, for example, we add a new hook to the generic part and the implementation specific one doesn't handle it, then reconciliation will never finish, right? Because even if implementation specific controller doesn't need to do anything, it still needs to remove the hook, right?
Yes, it depends on the implementation controller. Yeah.
Okay.
Vishay, I didn't get your last concern. Like, what's the concern?
So
like trying to understand, like, what's the problem?
For example, let's say that the generic provider exists and it has a set of hooks, and I have a controller that also knows how to react to that set of hooks. And then one day we decide to add a new hook, let's say to do the validations, but my controller doesn't yet recognize that hook. So in that system, we need to make sure that the components are synchronized, because if the implementation specific controller won't remove that hook from the CR, reconciliation won't finish.
I don't think the implementation controller has to be in sync, because you said the example of what if we add one more hook, right? So BYOH by itself will not add a hook. It will only add possibly a lifecycle point. So it is up to the implementation controller or a cluster administrator to come and add that particular hook. So you can choose to add the hook only when your implementation controller is ready to respond to it. So you don't have to be in sync with a BYOH controller.
I see. Okay, so the implementation specific controller is adding the hooks, and then the generic one is looking for those hooks when it reaches a specific point.
Yes,
Okay.
you can directly add the hook or add the hook in the form of annotation, or you can look for, you can register for lifecycle, that particular field that I showed. So if you just mention, I want to add this hook for this lifecycle point, then the Pivat controller can also add that hook as an annotation for you when it reaches this lifecycle point.
Okay, that makes more sense. Thanks.
Yes, Saran?
No, it's okay. It's fine. I just wanted to say exactly that. That's what I got. Thanks.
Okay, thank you. Okay, so moving on. So this is just how we can define a hook or an annotation, depending on what lifecycle point it is, what phase it is, and on what CR. And there are a few things I did not go into much details, like how can we propagate this lifecycle info? So it could be at the time of cluster creation. That is, if you define these lifecycle registration points in your cluster template itself, things like on CRs like BYO machine template, we can decide to pass on whatever hooks are defined on the BYO machine template to the BYO host while creation. Or since agent processes started by itself, I mean, started as a separate process on the host, we can pass command line arguments and saying, hey, these are the lifecycle hooks I want to add. So these are just different options. So I intentionally left it TBD because I wasn't sure if this is going to be the proposed solution, and we can get into these details later on. And changes to existing agent reconciler. One is for the API types to include the lifecycle field in all the specs. And then for each of these controllers, at that particular lifecycle point, we'll have to add the logic of checking, are there any hooks registered? If yes, create annotations. And if there are any annotations already present, then pause the reconciliation, don't proceed further. So these are minimal changes to the reconcilers. And then some things on hook failure. So it depends on the hook implementing controller to decide if something has failed, because the agent reconciler will not know that and just wait for that annotation to be removed. And hook ordering, it depends on, again, on the implementer to coordinate all sorts of ordering. And these are some guidelines on what the hook implementing controller should do. It should watch the BYO host objects and determine when an appropriate action must be taken. And on completion, it has to remove the hook annotation. It can also be that a cluster administrator can add these annotations and coordinate with other hook implementing controllers. And when does it have to take action? So basically, say you registered for a lifecycle point, the agent reconciler reached that particular lifecycle point and added those annotations and patched the BYO host. Since the hook implementing controller will be watching for BYO host, it will get a notification or a reconcile event when that particular object has been updated. So it can see that the annotation it is interested in has been added and start its validation. And then failure mode. So again, it depends on the hook implementing controller to determine something as failure. It will not be done on the agent reconciler side. So yes, this is the basic idea of how we can implement lifecycle hooks. Are there any more questions on this? Yes, Ashutosh.
Yeah, maybe I'll have to read this one. So again, no question again. So this controller that is going to implement the hooks, this controller will have to actually watch for all the possible CRs that is being watched by BYOH, right?
So
did I make sense? I can repeat my questions.
Oh no, it made sense. So I'm thinking not all possible CRs. So you're saying if you're interested in a BYO host, one particular host, how would you watch? Or is that your question?
So my question is like, there are events, there are life cycle points, right? And that is represented via annotations. So these annotations are put on the resources, on the CRs, right? And this type of annotation could be put on different CRs that BYOH is reconciling, depending on at what point, the event has progressed. So let's say BYOH manages 2 CRs, like CR1 or CR2, and both the CRs has possibility to get annotated. That means that if I want to implement that, I'll have to, the implementer controller will have to watch CR1 as well as CR2.
Okay, so if your lifecycle point is on, so you should know what CR your lifecycle point is on. So now this precates install is only on the BYO host, not on BYO machine. So in that case, you can watch only BYO host. Otherwise, yes, I think you have to watch whatever
so I think
CRs it's defined on.
Yeah, so I think if the admin wishes to actually utilize like all the possible annotations, then the controller will have to watch all the possible CRs where the annotation could actually come in.
Yes, I suppose so.
Okay, makes sense. Yeah. Thanks.
Any more questions? Yes, Abhishek. Yes, Abhishek.
We can't hear you, Abhishek. Mute something? I don't know.
Sorry, better now?
Yes.
Yeah.
Okay. Yes.
I unplugged the headphones by accident. So given this design, what do you envision that will be in the generic CAPI provider, and what do you envision will be left to some implementation specific controllers?
Yes, I think that is the next step that we need to decide. So what could be kept common and what should be delegated to implementation controllers? So for that, right now I don't have an answer, but yes, we should think about what should be common. So yeah, I think we can start a separate discussion on that. Is that okay?
Sure. I'm assuming that each implementation would have a different CRD for, I think you called it the BYOH host, what that agent process creates. With they might have different inventory, might have different whatever, and then we would want a common BYOH machine and cluster and all of that, right?
Yeah. So are you saying like we'll have to modify the APIs a little bit to fit into the use case?
Even before that, just the question, what logic will be common and what logic will be implementation specific?
Yeah.
Arisha, do you mind if I answer?
Yes.
So Abhishek, your question is like, what is the common logic that goes into CAPI?
Yes.
Like if I could understand right, like based on this proposal, I don't see any like.
No, I think CAPI as in the BYOH CAPI provider.
Yes.
That's what you meant, right?
Yes. So we have the general BYOH CAPI provider, and then we have some implementation specific controllers. So what, if anything, goes into the generic part?
Yeah, like maybe then Nusha can answer better. I thought it was regarding CAPI, but I feel that this CAPI BYOH should only have the mechanism for registration of this events, and then actual implementation will lie on the controllers and the implementer controllers, and then it is going to remove those. So, but yeah, Arisha can comment more on if there are any other.
So I think if we can come up with a list of what is missing from current BYOH for your use case, I think that would be helpful. because then we can see if it's something that can be usable by all, we can plan on implementing that in BYH itself. But if it's something very specific to your own use case, then I think we can start defining lifecycle points there so that you can hook onto your implementation there.
Okay.
Does that sound like a good next step?
Sure. Actually, the BYOH machine and cluster controllers overall look very similar to ours.
Mm-hmm.
But for example, like we want to choose BYOH host based on label selector. So, but we have different CRDs for the BYOH host. So we would need to have, more generic code that accesses the BYOH host as I forgot the name, the generic object.
Mm-hmm.
Like
So
we could do things like that, or we could just have life cycle points and make it super generic, which might be the best thing.
So I have one question that is in your implementation. Okay, this is in terms of BYH. So you have a BYH machine or an agent machine that is from BYH's perspective broken down into BYH machine and BYO host, right? And that's what allows us to have two different controllers here and do the declarative model. So is it possible to conform to what BYH CRDs are, or I don't know, we might have to do changes there as well. I don't know the changes on the top of my mind. But yeah, I want to say let's have an async discussion on this. That sound
Sure.
okay?
Sure.
Yeah, okay.
Iran?
Actually, I was thinking maybe, because it seems that I don't know what logic will actually remain in the BYOH CAPI, but perhaps we can have a default implementation here and allow different controller to override the lifecycle points. Like the lifecycle points are actually like whenever you actually want to do something. So maybe there should be some default implementation here just so it will actually do something, and allowing others to override the only or the specific logic that doesn't work for them.
Okay, I think we can ponder on that as well. I'll make a note. Yeah. Could you add that comment on this doc itself so that it'll be useful for everybody to take a look? Yeah, thank you. Okay, anything else?
I just want to say I would be okay with that as well. Like, so we could potentially have this BYOH implementation so that, when someone uses the CAPI provider, it actually does something without installing additional things. And then if they want, for example, our OpenShift specific implementation, then they could install that and it would work well together.
Mm-hmm. Okay.
You could also have this, a CI with the generic code that actually does something.
Okay. I think we can discuss on that too. Any other questions, comments? Cool. So next I wanted to talk about the Cluster API Runtime Sdk. So I found out about this just today morning. I saw Fabrizio's message in Cluster API channel. So what caught my eye was the runtime hook, because this is also an extension point allowing applications to hook onto specific moments in our workloads cluster lifecycle. And that's what exactly we're trying to do with the lifecycle hooks-based approach. And the second thing that caught my eye was, so they talk about how machine deletion hooks is just trying to solve a particular problem in a particular phase, right? Because this is tied to only the machine deletion phase. And I'm hoping this runtime SDK provides sort of a generic way to define hooks, implement these hooks. I think CAPI folks could have more idea on this. So I haven't gone through this complete doc. So I wanted us to like take a look at this to see if this actually works out well for us. Because if CAPI is already doing it, I see little value in doing a separate implementation of our own. But that being said, suppose say this does work out for us. We don't know how long it is going to take for CAPI to actually implement this. And if that timeline is okay by everybody else, like, are you okay to wait? If not, then we can go down the path of lifecycle hooks, keeping as close to the actual runtime SDK implementation so that we don't have to do much changes in future. So these were like some of the thoughts, but yes, Shailesh.
Yes, I would say maybe this CAPI API runtime SDK might give us the insights into the generic part that Abhishek and all we are discussing, right? It might actually facilitate having those generic portions implemented in the core providers and then extend into those specific providers that we are writing with the BYOH provider. That's my gut feeling, but we need to go through this proposal and see how it can help us.
Yeah. Has anybody gone through this proposal? Like, do you guys have more inputs?
I have gone through, but like I don't think like I have like a far better understanding yet. Like I went through on a high level. So just to reiterate, I think it's something similar to what you were speaking, Anisha. And if you scroll it down a little bit, you will see a diagram.
Yes.
Yeah. So it's something similar to what you were. So here, cluster API maintainers. It is where we define the points into CAPI, and then again the extension implementers. It is like almost similar with a little bit of spice. So yeah, this diagram.
I think Fabrizio is going to give a introduction in today's office hours, so I hope to catch the recording. And I think let's all try and review this if this fits our use case. Yeah, that's what I wanted to call out in this meeting.
Sure. Yeah, I think Fabrizio would be the right person.
Okay. Yes, Abhishek.
Okay, just a previous point about what Aran said. So he wrote that the generic, by generic he meant the unstructured. So that's a nice idea. So like we can access, instead of accessing BYOH host specifically in the controller, in the generic CAPI provider, we can access unstructured, and then it would work for all the implementations. Around, that's what you meant, right?
Yes, that's what actually CAPI is doing for each provider.
Right.
Okay,
And
interesting. I didn't know this unstructured a bit.
yeah, so like when, for example, when the CAPI's cluster controller itself is looking at the status of a specific provider, like vSphere, AWS, whatever, it'll use the unstructured, and each implementation needs to have, specific fields like status, status ready, or things like that. So if, BYOH host has some, some part of it that's that's defined for all of the implementations, and our version of BYOH host also has those same fields that we say everyone needs to define, then we can have a generic implementation that knows how to get to the label selector, how to get to the labels on the BYOH host in a generic way.
Yes, Ashutosh.
So I have one concern here, like if I understand it right. So you're saying that this BOHCRs will have those fields, that's gonna be parsed by the unstructured part of CAPI BYOH.
So let's say we have two implementations, and they both have some form of BYOH host. They would both CRDs would have, labels on it, obviously. And then the copy provider would access the labels via the unstructured library. So it wouldn't need to do, BYOH host dot labels. It would just do the unstructured dot labels. It could, we can set a standard for inventory perhaps, and then there would be like a generic way of figuring out how many CPUs a certain host has. We can see how far we want to take it, but Iran's suggestion is that we would always use this unstructured method of accessing the equivalent of BYOH host.
Yeah, the only thing that I'm trying to understand, maybe we can chat what this async is, that if we are processing any data via unstructured machinery also, and if that becomes too specific for a vendor, that means we are again tying interdependency, right? So I just sense that maybe I didn't understand completely, but if it is something like this, then maybe we could talk more.
Yeah, I guess I can, in 2 sentences, the idea is that from the bring your own host provider, the underlying provider, the specific vendor provider, needs to implement some spec that, in order to be in line as bring your own host specific provider. And if that's the case, then we can use this unstructured. If they don't all fall in the same line that implement the specific spec that this is what the real bring your own host API provider demands, then we can't use the unstructured, and we're going to have to have implementation specific logic in our generic provider, which is less.
Yeah, I mean, yeah, let's keep talking on this one. We could actually put specific comments on document. We'll see.
Yeah, I
Thanks.
think comments
Thanks,
on doc would be great, so that people not attending the call also could give inputs.
Sounds
Okay,
good.
so this is about the runtime SDK that I had. And yep, any more comments? Okay, cool. So next I wanted to take a quick poll that are folks okay with weekly office hours, or should we move to bi-weekly office hours? What do you all think?
My personal feeling is, like, right now we have probably more to talk about because we're trying to get this design worked out. So maybe weekly would be better, and then maybe if things kind of settle, then we can move to bi-weekly.
Okay. Any more comments? Anyone? Okay, I think weekly it is. Awesome. So I think Richard, I think he left the call. The status of donation to Kubernetes 6. So I think last month, like late last month, we got a +1 from all the cluster lifecycle siglates to move from VMware Tanzu to Kubernetes 6 org. Now we are working out some internal approval process to migrate the code to Kubernetes 6. So once we have that approval, we can then begin the process. So that's the update on migration to Kubernetes 6. Yep. So that's all we have on the agenda. And we have like 4 new folks joining us today. Do you want to introduce yourself, Ashutosh?
Yes, sure. Thank you. Hi, people. I'm Ashutosh, and I work in the cluster lifecycle team at VMware. So you can see me around in CAPI and cluster API provider Azure community. So happy to be here. Thanks.
Welcome. Shailesh, do you want to go next?
Hi everyone, this is Shailesh. I work alongside with Anusha, Jamie, everyone on the BYH provider side and other initiatives on the website. Happy to be here. I will try to make a point to attend regularly. I've not been very regular in these meetings. Hopefully I'll be regular. Thank you.
Thanks, Shailesh. Welcome. Geetika? Geetika, are you there?
Yeah. Hi.
Yeah.
Could you please repeat? I was just.
I just wanted to, like, we do welcome new folks at the beginning, but since you all joined 5 minutes late, we're doing it now.
Okay. Thanks a lot. So, do you want me to introduce myself quickly?
Yeah.
So hi everyone. I'm Geetika. I am working with I'm working at VMware right now, and basically my focus area is CAP provider with vSphere. But we all are as a team. I'm really interested with the BYO, with the edge use cases of cluster API. So yeah, yes. So I'm here. Looking
Welcome.
forward to our meetings. Thanks a lot.
Aman?
Yeah, so thanks, Nusha. So hi everyone, I'm Aman. So I'm currently contributing to Tanzu Community Edition project. And so I was, as the name is interested that BYO, which bring your own host. So just curious to attend this hour. So yeah, try to attend for later too. Currently, I don't have so much of idea, but yeah, if I got chance, I will try to explore this too. Thanks.
Thank you. Thanks for joining. Welcome, everyone. So yes, with that, we are done with today's agenda. Is there anything else? I think we can wrap up the call. Cool. So I think the AI is to comment on the lifecycle hook space doc with all the ideas that we discussed today, and then to go through cluster API runtime SDK proposal, see how it is relevant to us, possibly look at Fabrizio's recording tonight. Yes, I think that's all. See you all next week. Bye-bye.
Thank you.
Thanks.
Bye.
Bye-bye.
Thank you.
Thanks everyone. Bye.